f of x equals negative 3 raised to x plus 1 and minus 9. And you could say, what is this? And I would say transformations on the exponential function. So the question is asking us to list the transformations and graph this function using transformations. So you first will have to give me the base function that I used to create this. No, we have not looked at something like that. That's not the base function. You're very close though. Yes? And 3 is not a function. It's not exponential.
Yeah.
I used an exponential function, right?
Yeah.
So it's 3 to the
X.
Yes, that is the function that I used to create all this.
Right.
Very good. In order of operations, what would be the first transformation here?
What about when you said A can't be negative?
It's not in parentheses.
Oh.
I'm not raising negative 3 to x plus 1.
Oh, okay.
I'm saying 3 raised to x plus 1, and when I'm done, multiply by negative 1.
Yeah. Oh my God. Okay.
So, first transformation in order of operations.
X plus 1.
Yes, 3 raised to x plus 1, which is a shift where?
To the
Left 1. Very good. You thought we buried the transformations? No.
All this knowledge gets recycled. I can just forget about it.
No, you can't. Okay, next transformation. Transformation 2 is on function 1.
negative 3x plus 1.
What will that do?
Flips it.
Reflect. Very good.
Or reflect.
Yes, over the x-axis. Awesome. And number 3 is a transformation on number 2.
Down.
Exactly. Negative 3 raised to x plus 1 minus 9, down 9. Good. So here are the graphs using transformations, which means I'm not really looking at a super exact graph, but very soon we will be able to determine the x and y intercepts. And we should try right now. Okay, so here it is. Ready? So 3 to the x, very similar to 2 to the x. Then you said left shift of 1. So this point that is at 0, 1 will move at negative 1, 1. Okay. Still the horizontal asymptote stays the same. So this is 3 raised to x plus 1. Then you said reflect with respect to the x-axis. So then this point that I'm watching carefully will move here. So then the graph will be something like this. So this is negative 3 raised to x plus 1. It's all good. The horizontal asymptote stayed the same. But now I am shifting the green graph 9 units down. When I shift the graph with horizontal asymptotes up or down, I have to shift the asymptote first. Where will the asymptote y equals 0 go? Exactly. So bear with me, and let's say that this is y equals negative 9. This is the point I'm watching. Where will that point go? It's at negative 1, negative 1.
Negative 1, negative 10.
Exactly. So here's the graph. Of negative 3 raised to x plus 1 minus 9. Using transformations. Any questions? Any questions? Okay. For this function, I would like to ask 2 questions. Does it have an x-intercept? I don't care about these. I care about the function, not the step-by-step transformations. No. Does it have a y-intercept?
Yes.
How do I determine the y-intercept exactly? Because here I didn't determine anything exactly. Other than I watched a point which is correct, but I don't know where this, I didn't calculate anything here, right? So this was my marker
Right.
that helped me move the graph correctly. But I don't know this. How do I determine the y-intercept for any? Of course. So I have to determine f of 0. Let's do this together. How much is 0 plus 1? How much is 3 raised to 1? How much is 3 times negative 1? How much is negative 3 minus 9? So this point is 0 comma negative 12. Okay. So now there are 2 very important functions, both with base greater than 1. One is called common exponential function, and the other one is called natural log. I can't write today. A natural exponential. I didn't get to log. Natural exponential. Yet. Of course, we have those for log as well. Okay, the common exponential function has a base 10. So, which is greater than 1. So f of x equals 10 to the x. The name of this function is not just exponential function. It is exponential, but it's called common. There is also the natural exponential function, which is f of x equals natural log x. ln. Comes from German. So if I can draw your attention for a moment to your graphing calculators, I want to show you in the leftmost column, if you look at your keys, you will see one that is in blue or yellow. I don't know how your calculator looks like. Right under x squared, in blue or yellow, you see 10 to the x.
Mm-hmm.
And right underneath it, do you see e to, I'm sorry. I don't know why I'm already thinking of the logarithmic function. I'm sorry. Of course, I meant e to the x. We haven't discussed logarithmic function yet. I don't know. Keep me on track, please.
Yeah, he's the specific type of number.
Right, right. It's Euler's number. It was discovered like it was discovered pi.
Like 5. Right?
Yes, yes, Euler's number. Forgive me. So here it is. Right under that key, you see e to the x.
Right.
E is a number greater than 1. It's 2.7, blah, blah, blah. So both these functions look the same. The shape is the same. So if this is e to the x, I thought I pressed it. So if this is e to the x, this will be 10 to the x. How do I know that 10 to the x is closer to the y-axis than e to the x? Because imagine this is 2.7, and for x equals 1, this will be 2.7. For x equals 1, this will be 10. So the higher the base, the closer to the y-axis. So we can graph several functions if you'd like in y equals, clear if you have whatever. So let's graph 2 to the x. Let's graph 10 to the x. 10 power x. And let's graph e to the x. Second, e is right here, but e to the x is right here. So if you'd like to watch, because it's going to happen very fast, and the software has 3 different colors, as you see, blue, red, and black. So which one will be the closest to the y-axis? Which one will be next close? Yes, and then 2. So I expect that to happen. So let's graph. Please graph. Here it is, the blue. Okay. That's the 10, and now the e to the x. Right in between, somewhere. Okay? 2 to the x, e to the x, 10 to the x. Now we know that the calculator is lying here. It doesn't touch the x-axis. None of them. None of them touches the x-axis.
Just gets very close.
But we know what happens there, right? Okay. Eventually we say it may, but definitely not at -10. Although it's so tiny, but still not. So we understand the graph. Good. Any questions? I'd like to look at an application before we move on. So we are in 4.1. I'll find it in a minute. Okay. I want an application, maybe with compound interest. Yes, compound interest. Let's look at problem 52 on page 309. I know we did not graph the other shape yet. I know. I just want to show you an application. If $2,500 is invested at an interest rate of 2.5% per year, annual interest, compounded daily, find the value of the investment after the given number of years. A, after 2 years. B, after 3. And C, after 6 years. I am going to add here part D, redo all A through C for interest compounded monthly, interest compounded quarterly, and semi-annually. Also, I want to add one more question here, which is E. Same. If the interest is compounded continuously. This sounds very difficult. I would say quite simplistic, though. Okay. I'll come back and read everything, and we'll do it step by step. Okay. Interest formula. First, compounded. I'll explain what compounded means in a second. Compounded n times per year, one option, and compounded continuously. No, I do not expect you to memorize these two. I will give them to you. So the interest formula for compounded, if the interest is compounded n times per year. So you make an investment, and the bank calculates the interest and puts it back in your account, let's say once a year, or twice a year, or 12 times a year, which is every month, or 52 times a year, which is every week, or every day, which is 365 days or times per year. That's what it means. Compounded n times. Here's the formula. A equals P. I will identify each and every one of them. 1 plus R divided by lowercase n, everything in parentheses power nt. Uppercase A is the accumulated value. P, principal. The formula works if I deposit money. The principal is the amount of money I deposit, and also works if I take a loan. That's still the principal. R is the annual interest rate. T, time in parentheses in years. And N, what do you think N is? The number of times
Per year.
interest is compounded, yes. Number of times interest is compounded.
What is P saying? Period?
Principal.
Right?
Principal. P is the principal, the amount of money I deposit or I take as a loan. R is the annual interest rate. T is time measured in years. And N is the number of times the interest is compounded per year. Good. In the event in which the bank is compounding the interest continuously, then the formula is A equals P times E to RT. P is still the principal, R is still the annual interest rate, and T is still the time in years. Having these two formulas, I can go back and answer the questions. A lot of questions here. So what is 2500? I need to identify each and every piece of information. What is 2500? Of course. So if I use this formula, I will write 2500. If I use this formula, I will write 2500 times E, and I'll put in the rest. What does 2.5% per year mean?
R.
Yes, it's R, but I cannot put it in percent. It has to be 0.025. So this is 1 plus 0.025. And this is the R at 0.025. This is the R that I put here, and this is the R that I put here.
So what? I'm just writing here at E instead of the 1 plus.
So because I want to do
Oh,
both.
you're doing both.
Yeah.
Okay.
No problem. Okay. Now, they want us to compound the interest initially in the first part of the question daily. Daily means 365. And now the formula requires a power, which is n, which is 365, and t is the time. They're asking us to put 2 years, 3 years, 6 years. I'm not going to do that 3 times. I'm going to put t. And here, the same thing, t. I'm going to go to the graphing calculator. And in y equals, clear everything you have. And let's put in 2500 in parentheses 1 plus 0.025 divided by 365. Close the parenthesis caret. Do not forget to put parentheses. Maybe the new sophisticated calculators may work without parentheses. I can do it without parentheses. You know me already. 365x. There is no t in the calculator, and close. What do you think I am going to do next? So I want to evaluate the function. So I will go to
Window.
second and table. And I will put, of course, I'm sorry, I have to change my table set. I go to second and table. And what do you think I'm going to do?
Here's
Exactly. Put in 2, 3, and 6. 2, enter, 3, enter, 6, enter. I don't want to waste my time and plug it in 3 times. I put the function in and I have the answer. So I'm going to create a little table so I can put all the information in the table. So A compounded and N and time. I prefer putting time first, always. So time and A. So 2 years, 3 years, and 6 years. And continuous. So for 2, I got 2628.20. 2628.20. For 3, I got 2694.70. And for 6, I got 2904.6. Now I will go back to the viewing window, to y equals, and I will create the other function. I will put in 2500, second and e to the x, in parentheses, 0.025x, close, and go back to second and table. I don't have to do anything because I already have it. So for continuous, with 2, with 3, and with 6, I got 2628.20. I got 2694.70 and 2904.6.
Can you go back to the y one more time? I missed a second.
Sorry.
No, just the y equals.
This one? Oh,
Yeah, that's, either one is fine. I just missed it.
so 2500 times e to 0.025x.
Okay.
That was RT.
So
Why do you think that these are so close?
Aren't they the same?
Right, but why do you think that they are? Because continuously and 360 per year, continuously per year, and 365 times a year, it's pretty close. The difference is probably a fifth decimal. We can look and see.
Yeah.
Okay, so now I want to redo A through C, but now I want monthly. What changes?
So
Exactly, instead of 365, I would put what? 12, and also here 12, and also here 12, right? Okay, what about quarterly?
so
How many quarters?
4.
4. So then this will change into 4,
Yeah.
and this will change into 4. And then the time there is no change here, right? Just the time will change because we have different 2, 3, and 6 years. What about semi-annually? 2, and so on and so forth. Is it clear how the formulas work?
Yes.
Okay, very good. So can you finish it up? Not as a homework, but okay. So I would like to look at the other shape now. So let's say f of x equals 1/2 or 1/3. You want 1/3? Let's do 1/3. to the x power. Okay, we want to graph this. I need to identify first what? For any function I need to graph, I need to identify its domain. What have we established about, what type of function is it, by the way? It's an exponential. What have we established about all exponential functions? Yes. I will use the same numbers as close as possible to 0. So let's say -2, -1, 0, 1, and 2. So please give me plug in -2 and tell me what you get. Very good, awesome. Plug in -1. Very good. Plug in 0. Very good. Plug in 1. Very good. And plug in 2. Good. Just for exponential, I would like to determine the end behavior in this way. We've never done it. Please don't apply it to other functions. It may work, but please don't apply it. Okay, I'm going this way. 9, 3. Thank you. I'm going this way. So what does this mean? That this shape has a horizontal asymptote at infinity only. It's not the type of horizontal asymptote that exists at both ends like we are used to seeing. Okay, very good. So let's graph this function. -2, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Bless you, -1, 3, 0, 1, 1, 1/3, and then I get in trouble beyond that. So this is the graph of 1/3 to the x. And what can you say about this function?
Decreasing.
Always decreasing on all its domain. Awesome. It has a horizontal asymptote at infinity only. Does it cross the x-axis?
No.
Is it 1 to 1?
Yes.
Does it have an inverse?
Yes.
We'll graph it in a minute. Does it cross the y-axis?
Yes. Right. 0, 1.
Very good. Like any base exponential function. Good. So now please give me a couple of ordered pairs so I can graph the inverse function.
1, 0.
Yes, indeed, 1, 0.
1/3 1.
Yes. 1/3 1. Now be careful. Since the function crosses y equals x, the inverse must cross at the same point. Because at that point, it's not that ordered pair. It's like 1, 1. And if you reverse it, it's still 1, 1.
Right.
It's not 1, 1, of course. Okay. And so on and so forth. So this is the inverse function. It's decreasing like the original function. Is it a friendly function, the inverse?
No.
No. It has a vertical asymptote at 0, and it does not exist for a negative value. So, again, the same idea, exponential function is defined everywhere, but its range is 0 to infinity. Okay, I would like to graph one function here, like this one. And here I would like also to determine the x and y intercepts algebraically. But first I want to graph it using transformations. And then when I'm done, I want to determine the exact x and y intercepts. Because transformations are basically used to give us the quick shape. Boom, boom, boom. Not to present a super, yes.
Okay, but we didn't discuss one of the behaviors where, or I guess we mentioned it, but we didn't like highlight it, where if the base is greater than 1, then it's increasing, and then if it's less than 1, then
It's always the case.
I'm
Yeah.
just saying that's
Yes, always. If the base is less than 1, the function will always be decreasing. And if the base is greater than 1, the function will always be increasing. Like e to the x, 10 to the x, 2 to the x, 3 to the x, 2.5 to the x. Good. Okay, so I would like to graph this function using transformations and then find the x and y intercepts exactly. First, I have to identify the base function. I lost track of my numbers here. And if I drop them, I'm in big trouble before I scan them. Good. Base function, please. Very good. First transformation on 1/2 to the x.
shift to the
Yeah,
right.
so it's 1/2 x minus 2, right 2 units. Okay, and transformation number 3 is on number 2, which is, say it again?
Minus 4.
Yes, down 4. Very good. 1/2 raised to x minus 2 minus 4, down 4. Perfect. I will graph 1/2 to the x. When I graph a function with asymptotes, I have to graph the asymptotes first. What asymptote does 1/2 to the x have? Does it have a vertical asymptote?
Horizontal.
Right. It's not. It can never have a vertical asymptote because it's defined everywhere.
Yeah.
Correct. Very good. So 1/2 to the x is this graph. Because the base is less than 1, it has to be decreasing on all its domain. Good. Then you told me to move it right 2. I'm focusing on this point. I will move it right 2. So the graph will be something like this. I don't know how high. I don't care at this point. I'm going to find it. So 1/2 raised to x minus 2. Then you told me to shift this graph down 4. What do I have to shift first? Yes. So it will be 1, 2, 3, and I move the horizontal asymptote at y equals -4. And this is my marker. Where will I move the point 2, 1, 2? 2, -3. 1, 2, 3, 4. Okay, so this is the new graph. I have no idea where it crosses. I haven't calculated anything, and I'll go back and make adjustments. But obviously, the graph should look something like this. I don't know for sure, but this must be the shape. I don't know where it crosses. I don't know where it crosses. I will figure it out in a minute, and I can go back and adjust. So this is 1/2 raised to x minus 2 minus 4 for sure. And it definitely goes through this point. That's no question. Okay. How do I find the x-intercept of a function? Any function. For the x-intercept.
Left-hand side.
Y. So y equals 0, which means 1/2 raised to x minus 2 minus 4 equals 0. And you know what will be the first question I'm going to ask you here? What type of equation is this? If it has a square root, you'll say a radical or root, square root. If it has an absolute value, you will say the absolute value equation. If it's linear, you'll say linear. If it's quadratic, you'll say quadratic. But now here you will have to say exponential. Good. And you can also say you haven't shown us any so far. Yes, this is the first one. What do you think? Common sense. By all the algebra and factoring and simplifying and factoring and simplifying and staying simple, what will that skill tell you right now to do as the first step? Of course, yes. Well, there was no question there. Perfect. Now, I have to guide you for the next step. If I manage to show or present both sides with the same base, this will be an easier exponential equation to solve. If I cannot show or present both sides with the same base, then something else will happen that I need to apply later. So, can I present both sides with the same base? Well, the 4, obviously, I'm going to go with 2 squared because there is nothing else. Is there any way I could present this inside with the same base that I have on the right-hand side? And the answer is yes. Exactly. And I still have to copy the rest. Perfect. So now I copy the base, and what happens to these exponents? What operation I perform with -1 and x minus 2? Correct. So -1 times x is -x, and -1 times -2 is +2. And the right-hand side is 2 to the second power. I'm not simplifying, I'm not canceling, I'm not doing anything but this. I'm asking myself, 2 numbers are equal. That's what the equation says. 2 numbers are equal, and they have the same base. What has to happen? One more time. 2 numbers are equal, and they have the same base. What has to happen for them left to equal the right? Before you answer, I have a help question. Is 2 to the 10th the same thing with 2 to the 15th? No. So let's repeat the question then. 2 numbers are equal, and they have the same base. What has to happen? There's no other way. They will be equal if they have the same base, only if they have the same exponent. If they don't have the same exponent, they will not be equal. So therefore, -x equals 0, or x equals 0. It happens that that is the x-intercept as well as the y-intercept. So my graph was wrong. I'm not going to erase anything. I'm just going to adjust it. This is the correct point, but this is the correct point. So this is my correct graph. You don't have to delete it. Just do this, and that's good enough. This is the simplest possible, almost the simplest possible exponential equation. And yes, we will look at more difficult situations. Any questions? Any questions?
Well, that was to find the x-intercept.
Yes, but since I got x equals 0, in order to find the y-intercept, I have to plug in 0. When I plug in 0, how much is 0 minus 2? How much is 1/2 raised to -2? How much is 4 minus 4?
0.
So once I show that the x-intercept is 0, the y-intercept will be 0. Because the function is 1 to 1. Cannot cross the y-axis more than once, because it will not be a function, and it cannot cross the x-axis in 2 points. It will not be 1 to 1. Okay. I did write for today a classwork. I knew you were going to ask that. I had a feeling that you were going to ask that. And look at it and see if I'm fine with you taking it home. Or you do it in class. It's not a big deal.
So it basically says just to cosine, so sine squared.
Exactly how we did in class, and this is only 3 lines versus 3 pages that I'm exaggerating, there were not 3 pages.